Greetings, it's Paul again presenting you some three-dimensional examples of lengths and angles for vectors. I hope these may help you with some of the homework problems. I'm going to include the usual vector library, and for my first example, I'll imagine that you're standing near some great sporting event and you see both the Goodyear blimp and the MetLife blimp, and you know how far away they are from you in terms of three components: how far east, how far north, and how far up. Here are the two relevant vectors, and you already know how to calculate the angle between those two vectors, and it comes out in degrees. The angle is 104 degrees, slightly greater than a right angle. Not much to that. Second example. Let's think about a cube. We can invent elements of R3 that are the points in the bottom face of the cube. No harm taking one at 0, 0, 0. Add on the first standard basis vector to get another, the second standard basis vector to get a third, and the sum of the two standard basis vectors to get the fourth one. To get the vertices in the top face, we simply add the third standard basis vector to each of the 4 points in the bottom vector. Now for some terminology. Something that runs from vertex 1 in the bottom face to vertex 3 in the top face and goes through the center of the top cube is called a body diagonal. If you get into chemistry, you're likely to involve yourself with body diagonals. One mildly interesting question is, what's the angle between this body diagonal, a vector, and a side of the bottom face? No problem. We use the dot product, calculate our angle between function, and discover it's about 54 degrees. Another sort of diagonal on a cube is the so-called face diagonal. One representative face diagonal runs from the vertices I've called B1 and B3 in the bottom face. I just subtract them to get a vector that runs along this face diagonal. And if I want to know the angle between a body diagonal and a face diagonal, we've got the function that does the job. Finally, we could calculate a rather obscure distance. First, let's find the center of the bottom face in the middle of the face diagonal. We just take the sum of the 2 points and divide by 2. Let's calculate the midpoint of one of the edges in the top face. Again, add the points and divide by 2. And if we want to know the distance between these 2 points, we subtract them to get a vector and take its norm. Finally, and this is the most useful of the three applications, you can calculate the great circle distance between any 2 points on the Earth. And this is especially easy because there's a website called latlong.com that will give you the latitude and longitude of most any city that you're interested in. Here's Boston. Here's Oslo, Norway. And what I'm going to do now is, taking the radius of the Earth as my unit of length, I'm going to calculate a unit vector that locates each city. This means for the x and y components, I have to take the cosine of the latitude, which will drop to 0 at the North Pole, and multiply by the cosine and sine of the longitude. For the z component, I just need the sine of the latitude. Notice the capital letters, everything's in degrees, so I'm using the functions with capital letters that we have written. Same thing works for Oslo. How far is it from Boston to Oslo? Okay, this is not hard to figure out. We can certainly figure out the angle between the two unit vectors that represent Boston and Oslo. That angle is about 50 degrees. It's almost 1/6 of the circumference of the Earth, but not quite. Now we've got to convert to kilometers, and here the French bail us out. When the French in the Age of Reason were inventing the metric system, they defined the meter to be 1/10,000,000th of the distance from the North Pole to the equator along the meridian through Paris. Interesting, because at that time no one had been to the North Pole. So to convert to degrees, from degrees to kilometers, we just have to divide by 90 degrees and then multiply by 10,000 kilometers. And presto, we know it's 5,600 kilometers from Boston to Oslo. Or if we're true red-blooded Americans and don't recognize kilometers, we multiply by 5/8 to get the answer. And that ends this script. I hope it's useful.